Hi, and thank you for tuning in to Streakwave Learning Center. I'm Matt Jennings with Streakwave Wireless. Today we're going to be talking about system operating margin. System operating margin is really important when calculating a link. And I think sometimes we need to take a look at the nuts and bolts behind system operating margin and see what it really is. Okay, today we're going to talk about system operating margin, otherwise known as fade margin. Okay, two key components of system operating margin are the received signal, measured in dBm. And then we also have, and you're going to subtract your received sensitivity. Also measured in dBm. Okay, received sensitivity, let's talk about that one. Most manufacturers will post onto their spec sheets the numbers for their products. And so for a given product, I'm going to make something up. For a 50 megabit throughput for this given product, they have a received sensitivity listed of neg 83 dBm. And like I said, again, every manufacturer will have this chart. And so if you're looking to get 50 megabits out of your given link, you're going to need to use this number in your calculation to make sure that you get the desired throughput that you want. Okay, and now also we want to look at received signal, which is a big component of figuring out your system operating margin. So we'll start by just kind of working through this calculation, an imaginary link. We're going to do a link distance of 20 miles. And we're going to use 2.4 gigahertz. Use a received sensitivity that we looked on our chart, and we found a neg 83 dBm. And we also calculated for our 20-mile link the free space loss of 130 dB. Free space loss, let me just talk about that for a second. Free space loss is basically the given loss over distance. So if you're operating in a certain frequency, be it 2.458, there's calculators online on our website you could definitely use. You wouldn't want to sit here and calculate this out. But you can, for 2.4 gigahertz, there's certain properties. For 5.8, there's certain properties, and so on and so on. And over time, that link will actually degrade, or there's going to be some loss incurred over that signal over the distance. So at 20 miles, it's going to be X. At 25 miles, it's going to be X plus a little bit more, right? And that loss increases over time and over distance. Again, the easiest way to calculate it: go online, punch in your distance and your frequency, and hit calculate, and it'll come up with your number for you. So in this case, it's 130 dBm. All right. With that being said, let's look at this link a little bit further. So we have a radio, and out of that radio, our manufacturer spec says that our transmit power is 24 dBm. And we're going to use, in this radio, we're going to use some coax. We're going to go up to our antenna. Not a very big piece of coax, but 3-4 feet. And we like to incur a loss on that cable, because there is cable. Anytime you have coax and connectors, you usually incur some type of loss. So on the transmit cable, and we usually just say for this 1 dB of loss. Okay. And then out of this antenna, we've decided to use a 24 dBi dish antenna. Okay, that's a plus 24 dBi. And on the opposite side, we're also going to be using a 24 dBi dish. And coming down that cable, also going to incur a 1 dB loss again. and back into the receive radio. Now, it's at this point that we are trying to determine what our receive signal is. Okay, and we do that first by, we start by calculating the EIRP of the link. Basically, the EIRP is the effective isotropic radiated power, or in English, basically the total power minus all the losses of the link. So in this case, we have a 24 dB transmit power, and we're going to subtract 1 dB of loss for the cable, and we're going to add back in the 24 dBi gain of that dish that we're using. Okay. Now this should equal 47 dBm, and it does. Okay, now we're going to take our EIRP minus our free space loss, and then we're going to add the receive gain of the antenna minus the coax cable loss of the cable. Okay, so basically this is 47 dBm minus the free space loss, which we got from our calculator earlier, plus the receive gain of the antenna, which is 24 dBm, minus the coax loss of minus 1, for a total receive signal of neg 60 dBm. Check that out. So now we need, now we can calculate this, basically the system operating margin from this point. So we have a neg 60 dBm minus the neg 83 receive sensitivity number that we got from our manufacturer spec sheet. And that's going to give us a fade margin of 23 dB, which is well within spec. If you recall earlier, I mentioned about 15 is kind of the minimum where you want to see a link to call that good, and anything above, I would say 20 is really good. So we're at 23 dBi, or dB rather, for this link, and that would be a good quality link. I would go ahead and install this link. And that's the overview for system operating margin. At the bottom of this video, you're going to find a link to a calculator for system operating margin. I invite you to use it. I think it's very easy to use and be a lot simpler than what we just went through. Thank you for joining us, and I hope you really got something out of this video. And join us on, be sure to follow us on Facebook and Twitter, and keep up to date with all of our new Learning Center videos.